Hi, Math 2 students. Today we're going to go over kind of just some additional topics that we're going to add on to the 6.6 section here. So the first couple of questions should just be kind of a review of the beginning of 6.6, which is midpoint. So if you recall, the formula to calculate midpoint is x1 plus x2 divided by 2 for the first point, and then y1 plus y2 divided by 2. So we'll just say x1, y1, x2, y2. So I'm going to do negative 8 plus 2 divided by 2, and then negative 6 plus negative 10 divided by 2. Now, one thing you want to be really careful of is if you're doing this in your calculator all in one step, you need to put parentheses around the numerator, or else you're going to get it wrong. So negative 8 plus 6, negative 8 plus 2 is negative 6, divided by 2 is negative 3. And then negative 6 plus negative 10 is going to be negative 16, divided by 2 is negative 8. So that would be our midpoint there. Again, here, they ask us to find the midpoint. So I'm going to do negative 2 plus 5 divided by 2, and 3 plus negative 6 divided by 2. So that is going to give me 3 over 2, or 1.5. And let's see, we get negative 3 over 2. All right. And that would be my answer there. Let's see. Next one. All right, so this one, it gets a little bit trickier. What they do here is instead of just giving us our two endpoints, they give us our midpoint and then one of the endpoints. All right. So what we have to do here is we know that our midpoint we find from this formula, right? So what this means is that we're trying to find our other endpoint. So let's say our endpoint is going to be x, comma, y, right? Well, if our first endpoint is a, we'll say x1, y1. Oh, I guess instead of e for endpoint, we could just label this point b. And then we'll say that this is x2, y2. And kind of to visualize what's going on here is we have our endpoint A, our endpoint B, and then we have our midpoint M. All right. So what we can do is we can go ahead and say, well, I know that x1, which is 8, plus x2, which I just labeled as x, divided by 2, needs to equal the x coordinate of my midpoint. So that has to equal 3. And then my y1, which is negative 5, plus my y2, which is y, negative 5 plus y divided by 2, has to give me the y coordinate of my midpoint, which is negative 4. And then at this point, all I have to do is solve for x and y. So I'm going to multiply both sides by 2 here, and I get 8 plus x equals 6. I get that x is negative 2. And then I'm going to get negative 5 plus y equals negative 8. I get y equals negative 3. So the coordinates of b, which is my second endpoint here, is going to be negative 2 and negative 3. All right, let's try another one here. So it says the midpoint of AB is 1, 1. So again, we have our A point, our B point, and they give us our M here. So we're going to do negative 2. Actually, here, we'll say x, comma, y. And this guy is our x1, y1, x2, y2. So negative 2 plus my x value divided by 2 needs to give me 1. And my 5 plus my y value divided by 2 needs to also give me 1. So I get negative 2 plus x equals 2. X equals 4. And then I end up with 5 plus y equals 2. Y equals negative 3. So my endpoint here is going to be 4, negative 3. All right, I'm going to do one more of these, all right? So again, we've got A, B, and my midpoint. So just to keep in mind, usually, right, we average A and B, and that gives us our midpoint. So we've got B, X, Y. x1, y1, x2, y2. So my average of my x's, which is -3, and my unknown x, needs to give me a -5. And my average of my y's, which is 4 plus y all over 2, needs to give me a -2. So -3 plus x equals -10. X equals -7. Hold on. I did something wrong here. What did I do wrong? Let's see. -3 plus x divided by 2 equals -5. And then 4 plus y equals -2. Okay. Oh, we're good. Okay. Sorry, I had a brain fart. You know, it happens. We get -4. We get that y is 0. All right. So we should... Wow. Obviously, I am struggling. It's late, guys. I'm sorry. We get y equals -8. We should get -7, -8. All right. So now the next couple of problems, it's what we call Pythagorean theorem. It's a topic that is typically covered in middle school, but it seems like it may not have been covered for some of you guys, so I want to make sure we go over it. So it's a squared plus b squared equals c squared. All right. And this only works for right triangles. So that means that you have to have a right angle in there. And basically your A and B are going to be your legs. It doesn't matter which one you label A and which one you label B. You can flip-flop those, but the one that does really matter is what you label C. That's always your hypotenuse, and your hypotenuse is across from the 90-degree angle. So in this case, they're asking for us to find this missing side here. So we'll just say that that's my B side. All right? So we'll say that A is 9. We don't know B, and my C is 15. So I'm going to say 9 squared plus B squared equals 15 squared. So I get 81 plus B squared is 225. And then I'm going to do 225 minus 81 gives me 144. So to find B, I have to take the square root of both sides. Now, typically, when you add in the square root symbol, you have to do plus minus. But in this case, with Pythagorean theorem, you're just doing like a length. The direction of it doesn't really matter, so you don't have to do plus minus with Pythagorean theorem. In this case, when it gets more complicated and you go to higher level math, you might have to do that. But anywho, the answer here, square root of 144, is 12. All right. So let's go ahead and try another one here. So again, we're going to use a squared plus b squared equals c squared. My a, I'm going to put 8. My b, I'm going to put 14. Remember, a and b have to be the legs. If you have a hard time figuring out what the legs are, just think they make an L, right? Do you see how like this here looks like an L? Right, we got an L there. So keep that in mind. So we're going to do a squared plus 14 squared equals c squared. So we'll go ahead, 64 plus, I don't know, I forgot 14 squared. We get 260. Now, here we can just take the square root. So we get the square root of 260. Now, sometimes they may want a reduced radical. If you recall back when we did like quadratic formula, you had to take perfect squares out and simplify the radical. When it says to the nearest tenth, literally all you have to do is just plug it into your calculator. So the square root of 260 is 16.1. All right. All right. Next one. So again, there's another Pythagorean theorem. So stop and think, okay, what's going to be my A? What's going to be my B? And what's going to be my C? One of them is going to be unknown, okay? The one that has to be your C is 10, right? And we'll say that A is 9, and we'll say that B is what we're looking for. If you flip-flop the A and the B, it's no big deal. So we're going to do 9 squared plus B squared has to give me 10 squared. So I get 81 plus B squared equals 100. I'm going to go ahead and subtract 81 from both sides. And I get, is it 19? Yes, I just want to make sure. And then we take the square root of both sides, and we get that b is equal to the square root of 19. Now, of course, you want to see if you can simplify the radical. See if there's any perfect squares that can come out of 19. 19 is actually a prime number, so you're just going to leave your answer as the square root of 19. All right. Let's try the next one here. All right, so it says find the length of the third side. If necessary, write it in simplest radical form. So again, we want to find our A, our B, and our C. So the one that has to be our C is going to be 10 because that's the one that's across from the 90-degree angle. And remember, your A and B have to make an L shape, right? So we'll say A is 4, B is our unknown. So we're going to say 4 squared plus B squared equals 10 squared. So we end up with 16 plus B squared equals 100. 100 minus 16 is going to give me 84. So I get B squared equals 84. All right. So then I take the square root and I get that B is equal to the square root of 84. Now, of course, we have to go through and see if we can simplify this. So if you recall, to simplify radicals, you need to use perfect squares. So perfect squares are numbers like 4, 9, 16, 25, 36, 49, 64, 81, 100. I don't think with these problems it shouldn't go higher than 100. I would be kind of shocked if it got that high. But I guess maybe it could, 121, 144. If you have that high of a number, you should obviously check those. All right, so for 84, I should start checking all numbers below 84, right? So does 81 divide nicely in? No, it does not. 84 divided by 64. All right, and then we'll do, so we tried 64, 81 divided by 81, not 81, 84 divided by 36 does not work. 84 divided by 25 does not work. 84 divided by 16 does not work. 84 divided by 9 does not work, and 84 divided by 4 does work. Now, if we tried all of these and none of them worked, we would just leave it as a radical 84, but we can break it down into 4 times 21. Then we take the square root of 4, which is 2, and we get 2 root 21. So that would be our answer here. All right, next one. So here they gave me both my legs, so those will be my A and B. So we're going to say A equals, B equals, and C equals. C is the part we're looking for. A is 3, B is 3. So we're going to say 3 squared plus 3 squared equals C squared. So we get 9 plus 9, which gives us 18. So then we take the square root, and we get that C is going to be the square root of 18. Now, of course, we have to go ahead and see what perfect squares might go into 18, right? So for 18, we can take out we should do 9 and 2, right? So if you look at your list of perfect squares, right, you could start with 16. Does 16 work? No. Then you try 9, and 9 does work. So you get 3 root, oh my goodness, root 2 is your answer here.